A technique developed in Newark shows promise as a way of measuring how much carbon in the atmosphere comes from burning fossil fuels. The same technology might have applications in the pharmaceutical industry and in carbon dating, according to the Rutgers physicist leading the effort. Science and technology correspondent Patrick Regan has the story.
The naturally occurring isotope known as carbon-14 is radioactive for a few thousand years, a period long enough for scientists to consider it a stable, relatively constant part of the CO2 in the atmosphere. In contrast, the carbon released by burning fossil fuels has been in the ground for millions of years, way too long to have radioactive carbon-14 in it. So, physicist Dan Mernick reasoned it should be possible to put a meter on carbon emissions by monitoring the ups and downs of carbon-14 as a fraction of atmospheric CO2. Despite increasing interest for environmental and economic reasons in atmospheric carbon emissions, there really aren't many good ways to measure them. When people talk about carbon footprints or carbon credits, the numbers come from calculations based on energy use. Mernick's research group has been honing tools for direct measurement in the breath for medical diagnostics and drug testing, or in air. They're harnessing an effect discovered a century ago in neon lights.
The optogalvanic effect is a fancy name for electrical change due to light. So if you shine light on an electrical discharge and that light resonantly interacts with the discharge, the electrical properties change. We put our sample of carbon dioxide inside a laser cavity. So it has very intense laser light, and the effects on the light are too tiny to measure. But electrical properties are very easy to measure, and you can measure them with high sensitivity.
Recent experiments show sensitivity beyond what's needed for medical and pharmaceutical applications, bringing the carbon meter closer to reality.
We're hoping that we can develop a smaller system that can monitor the CO2 in many sites, because that's what you want. And that's the goal, to miniaturize the system.
Patrick Regan, NJN News, Newark.